Yes. You describe a simple form of AC generator and use a slip ring when needed. Sketch a graph of voltage output against time for simple AC generator.
Okay, so we are having discussion on this. So you write the heading AC generator, huh? Write the heading AC generator. So are you seeing the diagram?
Yes.
Okay, so first understand it, how it works, what is the structure of it, then you continue. Huh? So in this diagram we are seeing, excuse me. So we have here magnet, right? And magnet, we have magnetic field lines in magnet. How the magnetic field lines are working, we know from north to south, right? This way, magnetic field line direction. Then we are having, previously we had split ring. Now we have
Slip rings.
slip rings. And previously we got electricity supply, power supply, which one was connected to the carbon brass. uh, and now the slip rings connected to the electrical load. That means by this rotation or movement of the coil, you will have induced EMF, and that induced EMF will produce induced current, and that current will go, we will get through this electrical load. Is it clear?
Yes.
Okay. So our rotation of the coil, you see, is showing. That means there is turning effect of the coil, right? We are giving
Yes.
turning effect, and due to this turning effect, you see it's clockwise rotation, right?
Yes.
So due to this clockwise rotation, if you think about BC, if you think about BC, the BC part is moving downwards, right? Here, isn't it?
Yes.
And AD part is moving upwards here. So you can think of any one of them, like AD or BC, any one you think of, to get the direction of induced EMF using right hand rule, Fleming's right hand rule. Which rule?
Right hand rule.
Fleming's right hand rule. So Fleming's right hand rule gives you the direction of the force or motion, that is for BC, part BC, it is downwards, right? So your right hand you use and you keep your thumb downwards. Okay, got it?
Yes, sir.
Then then you place the forefinger or index finger to the right side. Which one is showing you the magnetic field lines? Are you done with
Yes.
that? Then you see your middle finger is towards, uh, or you can say towards you, or you can say away from the screen. It's away from the
Yes.
screen, right? It's matching, right? So in part BC, the part BC, we are getting the current, away from the screen or towards you. That one is shown in the diagram. You seeing in the diagram?
Yes.
So the other side, AD is moving upwards. So in AB, sorry, AD, uh, in AD, part AD is moving upwards. That's why the current direction will be towards the screen.
Yes.
And there is also magnetic field in the same direction. That's why it is towards the screen. So we are getting here flow of current in the same direction, isn't it? The current is going from here. Uh, if you show the direction of the uh, you know here, if you show the direction like this, uh, it's coming here, right? This side. So the lower side will be positive, isn't it? Uh, do you
Yes.
agree? Do you agree? So the conventional current flow across this electrical load will be this way, right? This side, the lower side is positive and the upper side is negative,
Yes.
isn't it? Now you're having the first, half of the rotation. If we turn more, the rotation continues, then AD will be also coming to other side, right? And
Yes.
BC will go to the other side. That time we will have uh, here the direction of BC and AD changed, isn't it?
Yes.
Direction of BC and AD will be changed, that is reversed. So the current direction through them also will be reversed, isn't it? If
Yes.
it is reversed, as it is unlike split ring, there will be, you know, change in direction also in the electrical load uh, currents. Why? That one I'm explaining now. Look, this is not split ring, this is slip rings, right?
Yes.
So here, this side, carbon brass, look, left side carbon brass
Yes.
is connected to AD, right?
Yes.
And right side carbon brass is connected to the part BC.
Yes.
So when it rotates, what happens? BC is going to other side, AD is coming to this side. The magnetic field, the way working on them, it is opposite, right? But their connection with the load is still same, isn't it? Look, if it is rotating, yeah, BC is
Yes.
rotating to going to other side, then what happens? Our connection of BC is still with this side, right side carbon brass, isn't it?
Yes.
Uh, and this left side carbon brass is still there and it is connected to AD. So that time AD in AD the current flow will be negative in this side, right? Now from AD we are having positive, isn't it? Hello,
Sir, I didn't
This,
understand.
yeah, this part you have to understand very carefully. Otherwise, you'll be confused. Now, current is flowing in AD in this direction, right?
Yes,
And from CB, it's coming with this direction. So we can say here it is negative and here it is positive, right?
yes,
Can we say? So
yes, sir.
when it is so, we are getting here electrical load. Here is negative and here is positive, isn't it?
Yes,
Now, if it is reversed, it is coming to here. Then in AD, we are getting negative, isn't it?
yes,
But AD is still connected to this side, lower side of the load. You see, it is slip rings, right? So this ring is moving, huh?
yes,
Yeah, and I'm showing it in the next diagram, then it will be clear to you. Otherwise, here, huh? You understand now?
yes,
AD is still connected to the left side, huh? Now it's clear,
yes, sir.
and BC is still connected to right side, isn't it?
Yes,
So in BC part will get now positive, huh?
yes,
Because it's going from BC to AD, right? BA. So look here. This side, upper side will be then positive, and lower side will be then negative. Is it clear now?
yes,
So if it is clear, then you understand one thing, that when we have rotation of the coil, every half turn, the direction of induced EMF and induced current is also altering, isn't it?
yes,
And that's why for every complete half turn, we are getting positive. That means positive and negative reversed. We are getting alternating current across this electrical load. We are getting alternating current. Is it clear?
yes,
So that's the benefit of slip rings. That in this arrangement we are getting alternating currents, right? And the amount of current, it depends on the amount of current, it depends on the magnetic field lines cut, right? Changing magnetic fields. Is it clear to you?
yes,
No?
sir.
So magnetic field lines is not cutting for all the positions in the same way. Which position the magnetic field lines are cut more, that position we are getting more induced EMF. Okay, hello.
Yes, yes, sir.
Like where it is north pole and south pole, uh, very much straight, that part we are having more magnetic field lines, isn't it?
Yes,
And uh, and where we are having the magnetic field lines cut by the coil most. That's why in this position we are having most electric current, induced current, or most electric induced EMF. But the other positions where we are not getting that much cut of the magnetic field lines by the coil, we are getting less induced EMF. And at one stage where when it is vertical, like BA, it is now horizontal, right? When BA is vertical, that we will have least cut of magnetic field lines, isn't it?
Yes.
And that time we have EMF is almost zero or zero. Is it clear?
Yes.
So all these things we will need uh, for writing, and we'll have also drawing. So please start this drawing first. Uh, this one. So first you carefully draw it, label everything carefully. Then the explanation I am giving you also write them. As the coil is rotated clockwise, there is induced induced EMF current in the loop, and according to according to Fleming's right hand rule, so this part you understood, LT, what I wrote?
Yes, sir.
Uh, we are getting the conventional current flow direction, and other things already we discussed, like magnetic field lines are cut over there. We know that one. Now we are having one thing, that is we are having here we are having having here varying varying uh, induced EMF or output depending 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 on the position of the coil in bracket to write how the magnetic field lines are cut by the coil. Okay, then we have here slip rings. We are writing the function of slip rings. Already we know the function of carbon brass, right?
Yes.
So that one will not continue or will not repeat. Just we say about slip rings. Slip rings play here vital role to alter the direction of induced induced EMF every after after as the coil rotates as the coil rotates as the coil rotates induced EMF reversed after every half turn. Slip rings play here a vital role to alter the direction of induced EMF every half turn. As the coil induced EMF reverse, uh, induced EMF reverse is reversed after every half turn. Okay. Uh, it's clear to you. This description is clear to you. Hello.
Yes, sir. Yes, sir.
So we get alternating output across the electrical load so we get alternating output across the electron every half turn. So whatever we discussed, I think if you draw this diagram completely and you write this statement, that will be enough. If you want to draw another diagram, the reverse direction, that one you can also do. What you
Yes, sir.
want? You want to draw
Sir,
another diagram?
yes, anyone.
Anyone? Okay, so write this one, and the other one will come in our description, right? This description,
Yes,
that will be enough. And your book is also there, so I think one is enough to understand other. The other one is just opposite, right?
yes, yes, sir.
So that's why the teachers are teaching this topic at last, as it is a little bit difficult to understand by the learners. Complex, right? Many ideas are
Yes,
working together. Our mind is like that. We cannot focus many of the things together.
yes,
Uh,
sir.
there is some level of knowledge or age level required to understand these things. So, are you done with writing and drawing?
Almost.
Yeah. Let me know once you are done.
Yes, sir. Done.
Okay. Now we will do AC generator graph. You write the heading AC generator graph. So here we understand one thing, that is in generator, from kinetic energy we are getting electrical energy, right?
Yes,
And in motor we get kinetic energy from electricity. Clear to you, right?
yes, sir.
And in generator we are using Fleming's right hand rule to get the induced current direction, and in motor we are using Fleming's left hand rule to get the force direction. So it's clear, right? The difference between
Yes,
a generator and a motor is clear, and which rule where we are applying, that one also you should remember. Hmm. This is AC generator graph. So you already wrote the heading, right?
yes, sir.
And now we are seeing the diagram. Look, they are showing you the position of AB. In the first diagram we got AB. I'm showing you again. We got AB horizontal. Left side was A, right side was B, right? In the first diagram, isn't it? So
Yes. No,
AB horizontal position, huh? And in in the AC generator graph, we see it AB horizontal position, huh? And one thing I told you that this position AB, we are having maximum magnetic field lines cut, right? That's why we are having maximum EMF. You see, E E not, huh?
So when the AB is in the horizontal position, it is basically in rest, like it is in stationary position, right? Like
No,
when
actually
it's
we are showing continuous rotation. Yeah. So we are
oh
thinking that it's already started before, and during the motion, it's not like that we just started at that time. It was there, right? Rotation was there. And what happens in A? What happens in AB? Like this position, uh, vertical position. What happens if uh, AB is in this reverse position? We are going to analyze that one. Already it's in rotation. Clear?
yes,
Okay. Now, when it is AB, we are having the clockwise rotation of the coil. So that time we are having we we can consider any side positive, any side negative. Just we are identifying one is reversed of others.
yes,
Is it clear? That one is our focus. So if we are thinking this upper side when it is in position, if it is negative, no problem, and the next one will be positive. Okay, is it clear? No, do you understand
yes,
what
sir.
I'm saying? Okay, so here we are showing E naught E0, huh? That is our maximum EMF when it is in AB position, and you see here we are having uh, this one is showing us displacement, right? Displacement, that means all from 0 to we are getting some values, right? So
Yes, sir.
it came to maximum from 0 it started and it's coming to here. Like here magnetic field lines are cutting least, that's why we are having less displacement. And in this position when it is in horizontal position AB, that time we are having maximum magnetic field lines cut, that's why maximum EMF produced. That is
Yes,
displacement is maximum, and that is called amplitude, huh? So this way again it's moving upwards, again it's decreasing. And when is it vertical position, then we are having no magnetic field lines cut, we are having EMF 0. Is it
yes,
clear? Now from this position again rotating, so it's coming to position AB, reverse like this BA. So here we are getting again maximum EMF, but in opposite direction.
yes,
Clear? Like we got
yes, sir.
positive, negative, negative, positive, that way across the electrical load. So it's clear, right?
Yes, sir.
So you draw this EMF, y-axis, time, x-axis, and here time period T for complete cycle, and every half turn we are having this one uh, d by 2. So draw it,
And both the graphs are only this one.
only left side one, not both the graph.
Okay.
You must show this 0, then E naught minus E naught,
Yes,
maximum positive, maximum negative, so that we can see it is alternating EMF, right? Uh,
Done, sir.
Done. This one is done. Okay, very good. So we are done with this. Uh, we are done with this AC part, right? AC generator part. These two, huh? D and
Yes.
E. In our next class, we will continue transformer. Huh? Have you read this whole unit from your textbook?
So not the whole one.
Okay,
I will
so
read.
you now already you understood from AC till AC generator, so that we don't need now. You just read transformer part. Okay, transformer
Okay,
part in
sir.
your book is from here. I am not giving you that much homework. Just you read from transformer part. Okay, read, huh?
Yes, sir.
As much as possible. If not possible, then don't read all the thing. Just few pages, 2 3 pages here. Huh? You read, huh? Till here you read, huh? 37. Okay. Yes. How much it is? 377, right? Page number three. Yeah, 73. 373. Okay. So you read from 370 to 373. Okay.
Yes, sir.
4 pages you read from your textbook. Okay. Allah Hafiz, huh? Okay.
Okay, sir. Allah.